Thanks for the introduction. What we are seeing as a trend, at least in the tech industry, is we experiment everything. I mean, literally everything. Whether it's Facebook, Google, doesn't matter. We do. However, there are pitfalls to consider while A/B testing. That I just mentioned a few of those things. There are shortcomings of the frequentist A/B testing that Bayesian A/B testing trying to alleviate. However, there are also shortcomings of the Bayesian A/B testing that you were mentioning, and that the sequential A/B testing is trying to alleviate. So it's more like a cutting-edge continuous research going on parallelly as we see as we move forward with the hypothesis testing. And I have shared 2 notebooks that you can take a look at it. It should run end to end. Just to give you a feeling of how frequentist A/B testing and Bayesian A/B testing works. And I haven't covered any of these topics that are probably so these things probably cover 80% of the business cases in industry. These probably cover another 20%. And there are pre-existing bias. So I give you one-liner example of each one of these. So pre-existing bias, what is it? Let's say again, I started a marketing campaign, but I reached out to users who are already prone to, they're just heavy shopper. They just buy anyway, right? So that's a pre-existing bias in the experiment, even before the treatment is happened. So what I will end up looking is I will see a 30% lift, but in reality, maybe that lift is 20% because there was that biased users that existed. And there are techniques to correct for that, and it is important to correct for that. Collision effect, I think we mentioned and discussed at length in the beginning of the talk. Causality is another way of testing. This is again where machine learning comes into play, where you are essentially it's a time series predictions of what's going to happen next, given a feature being introduced, and you are trying to see the difference between being introduced versus not being introduced. Synthetic control variate is another interesting idea, and there is actually a good study of that. I think the tobacco ban in California happened sometime in 1980s, and the goal was what was the impact of that ban on the tobacco in industry, or the consumption, right? So we want to see that a drop, right? And the question is, well, has that ban impacted? It was actually not a ban. It was probably an extra tax being levied on the tobacco sometime in 1980s. And in 80s, I think, other than California, not many states in the US had that ban. So how do you measure in that case if the entire state is a treatment, right? You don't have a treatment control in that case. So what you can do is you take other states, New York, New Jersey, etc., where this ban was not imposed or this tax was not levied, and you create sort of a synthetic California out of those states, and you see what the impact of that, not having that tax was on the tobacco consumption versus California, and you can make a decision if that tax levied was a statistically significant impact on the consumption going down on tobacco in California. So that's one example of a synthetic control study. In fact, it was one of the first studies in synthetic control. So yeah, the literature, people talk about A/B testing. We just talk about 1 or 2 things, and probably that cover most of it. But then there are all this whole, list of topics that, up and coming up that we require to solve some of the complicated problems. Yeah, so Monte Carlo simulation, I think it's in the notebook. Yeah, so basically there are 2 ways that we can do, calculate this probability. One is we can find a closed form expression of that probability. However, it's very numerically unstable and it can lead to a very incorrect answer. That's why I said don't try it at work, only try it at home. A better and robust way to do this is a Monte Carlo simulation, and it's an age-old technique to do any high-dimensional integration. So all we are doing here is an integration, and if an integration is unstable, Monte Carlo technique is a way to do that integration, and it's more robust. What you are asking is what happens after the experiment is done and we have a 100% rollout. Do we monitor the impact or not? Yes. We do monitor after the 100% rollout. At that point, it's not so much of a data science thing. It's more like an engineering monitoring thing. And if we see that feature don't have any effect, like it dies out, then yeah, something is wrong, right? So it's not a perfect science. We will have maybe 30%, 40% bad features. You would be surprised that it's not that popular. Maybe because it's a new method. It really became popular in the last 3-4 years. So surprisingly large number of people still use frequentist A/B testing. So I will stop here, and thank you very much.